Welcome back, dear grade 9 students, and now we are going to talk about more and more training exercises, including proportions and percentages. And here we go. A box contains balls of different colors. 2 out of 5 or 2/5 of the balls are green, 10% of them are red, 15% of them are blue, and 42 exactly balls are black, sorry. So we don't have the number of green balls, neither those of red nor those of blue, but we have the number of those who are black. Now the first question is to find the percentage of black balls. So I need to find the percentage of black balls. In part B, I need to deduce the total number of balls. Usually to find percentages, as if you remember, I write, for example, in the total number here, there are 42 black balls. So what about in 100 as total? And I find the percentage. That's the usual way to find the percentage. But here, I never have the total number of balls, so this method is not going to work. So I'm going to think of another way how to find the percentage of black balls. Let's think a little bit. I can benefit from these percentages, I guess. But how to change 2 over 5 into a percentage? Let's see. To change 2 over 5 into a percentage, all what I do is to multiply it by 100, just like this, as simple as possible. So 2 over 5 times 100 is going to be 40%. That's the percentage of the green balls. Now, if I subtract 100 minus the percentage of the green balls, which is 40, plus the percentage of the red ones, plus the percentage of the blue ones, I'm going to get 35%. Which is the percentage of the black balls. So this is the way here how to find the percentage of the black balls. I'm going to change this fraction or this ratio into a percentage, as you see here, by multiplying it by 100. Then I subtract from the total percentage, which is 100, to get the rest for the black balls. Now here I'm going to find the number of the total number of the balls. So what should I do? It's very easy. I use the black balls for the black. There are 35 in 100, so 42 are in how many total number of balls? All what we do is cross multiplying the numbers. 100 times 42 divided by 35, and we get 120 balls in the whole box. So this is the total number of balls. So again, 35% is for the percentage of black balls. So 35 and 100. So the 42 balls given in the question are in how many total number of balls? We cross multiply to get that there are 120 balls in the box. Okay? And here is a different kind of exercises. Find two real numbers, x and y, that are directly proportional to 3 and 4 respectively, such that the difference of their squares is 28. So again, I need to find two real numbers, x and y, directly proportional to 3 and 4. What does that mean? How should I translate this mathematically? Solution. We write it as follows: x over 3, y over 4. That's what we mean by respectively. So x goes to 3, y goes to 4. But that doesn't mean that x is equal to 3 and y is equal to 4. No, x is proportional to 3 and y is proportional to 4. Now, the difference of their squares is 28. So I need to make their squares, but I cannot square the numerator without squaring the denominator. That's why I write it as follows: x squared by squaring x over 9 by squaring 3 equals y squared over 16. But since the question says that the difference of their squares, then I'm going to subtract. But I have to subtract, and I have to put the bigger one minus the smaller one to get a positive number. What is the bigger number? Why did I put y before x or y squared before x squared? Because x goes to 3 is proportional to 3 and y is proportional to 4. So definitely y is the greater number. That's why in subtraction I care about putting the larger number before the smaller one. And I have to think which one of them is the larger. The larger is y because it's proportional to 4, which is greater than 3. So x is going to 3, y is going to 4, then definitely y is the larger number. That's why I write y squared minus x squared equals the number corresponding to y squared is 16 minus the number corresponding to x squared, which is, as you see here, 9. So this 16 comes from here and this 9 comes from here. And as I make a minus sign here, I have to subtract also here. Now where did 28 come from? Here. It's from the given. The difference of their squares is 28, then I have to substitute 28 in place of this. And 16 minus 9 is obviously 7. 28 by 7 is 4, and this is what we call the constant k. Note that I write here that y is greater than x, and I mentioned the reason. Now I found the constant. How to find x and y? I go back to x squared over 9 equals 4 by cross multiplication, then x squared is 36, then x is plus or minus radical 36, which is plus or minus 6. Because it's a variable, I have to find the square roots of 36, because plus 6 or minus 6, 1 squared will give me 36. Similarly for y squared over 16 is 4, then y squared is multiplying 16 by 4, I'm getting 64, then y is plus or minus radical 64, which is plus or minus 8. Thus the real numbers are x goes to plus or minus 6, y goes to plus or minus 8. Note, if in the question is written natural numbers and instead of real numbers, if it is natural, okay, then minus 6 and minus 8 are said to be rejected. So if in the question find two natural numbers x and y instead of real numbers, then I have to reject the negative ones. But here there is the word real, so a positive or a negative are both accepted. The other question is like little bit similar to that one, but it differs a little bit. The sides a and b of two squares are proportional to 2 out of 3. Then a goes to 2 and b goes to 3. Okay? Find these sides a and b if the sum of the areas of the two squares is 26. So if I have a square of side a and a bigger square of side b, as you see here, then what's the area of this? It is a squared. What's the area of this, which is of side b? Its area is b squared. Then we are going again to deal with squares because I'm talking about the sum of the areas of these two squares. So let's continue. How to represent a and b that are proportional to 2 over 3? I mentioned it. A goes to 2 and b goes to 3, and we put an equal sign between them. Now again, because I'm talking about areas, as you see here, I have to square a up and down, and to square b also the numerator and the denominator. So a squared over 4 is gonna be equal b squared over 9. So if a over 2 and b over 3 are proportional, then a squared over 4 and b squared over 9 are also proportional. Now I can add also a squared plus b squared and 4 plus 9. Regardless of the greater one, because I am adding, but here because I have the difference I need to put the larger minus the smaller, but here I don't care because I am adding, so never mind which one is before the other, the smaller or the larger. So a squared plus b squared because it is the sum. The sum means plus. I add a squared plus b squared. That's the sum of the areas as you see here. And I add the denominators also. 4 plus 9. A squared plus b squared is given by 26. The sum of the areas is 26. And the sum of the denominator as you see here it is 13. 26 by 13 is 2. Now I need to find the sides. A squared over 4, I take the squared one. Of course, I should take the squared one. A squared over 4 is equal to this k, which is 2, cross multiplication. Then a squared is 8. So a is plus or minus radical 8, as we did here and here. So plus or minus radical 8 to get rid of the square. Then plus or minus radical 8 gives plus or minus 2 radical 2. Similarly for b squared over 9 equals 2, then b squared equals 9 times 2, which is 18. So b is plus or minus radical of 18, which is plus or minus 3 radical 2. But can sides be in negative numbers, in negative measurements? Definitely no. That's why I'm going to say that minus 2 radical 2 and minus 3 radical 2 are rejected. They are never accepted, since the measurements of sides are always positive values. So here the only answers are a equals to plus 2 radical 2, only plus 2 radical 2, and b equals only 3 radical 2 without the signs, because as you see here negatives are rejected for measurements.